going to start with the physics chapter, that is the simple machines. Simple machines. Machine is a tool. Yes, machine is a tool that makes our work easier. Machine is a tool that makes our work easier. Machines can be simple or can be complex. Yes, so simple machine is a simple device. Simple machine is a simple device with few or no moving parts. For example, knife, bottle opener, all these are simple machines. And complex machines. So there are two main types, that is simple machine and complex machine. Simple machine and complex machine. So simple machine is a simple device with few or no moving parts. It is a simple device with few or no moving parts. Whereas complex machine, it is made up of two or more simple machines. It is made up of two or more simple machines. So this is the difference between simple machine and complex machine. Yes. So students, example for complex machine. Example for complex machine, that is bicycle. So bicycle is made up of many parts. Yes, it is made up of many parts. Car is made up of many parts. It is made up of two or more simple. So these are the examples for complex machine. Now let us see what is work. In science, the word work has a different meaning. In science, work is done. Work is done when a force is applied on an object or on a body. When a force is applied on a body, the body moves in the direction of the force. Then only we can say that the work is done. So for example, if I try to push a table, or if I want to lift a table from one place to another, I need to apply force. Or if I need to push a table, I need to apply force. Right? So then only the table moves from one place to another. Then only we can say that the work is done. So when you apply force on a body, the body moves in the direction of the applied force. Or, in other words, work can be defined as the amount of energy needed or transferred to move an object. So, in other words, work can be defined. So, in other words, work can be defined as the amount of energy. Defined as the amount of energy needed or transferred. Yes, amount of energy needed or transferred to move an object. Transfer to move an object. To move an object. So this is the definition for work. So there are two definitions, that is work is said to be done when a force is applied on an object and the object or the body moves in the direction of the force. All work can be defined as the amount of energy transferred or needed to move an object. Now, there are two factors which decide that the work is being done. The first factor is the movement. There are two factors which decides whether the work is done. There are two factors which decide the work is done. Yes? So here the two factors, that is first one is the something has to move. Something has to move. If you apply a force on a table or a chair, so then the chair or a table should move from one place to another. Then the motion takes place. The movement takes place. Yes? So motion can be in the direction of the applied force. So these are the two factors that decide whether the work is being done. That is, first one is something has to move, and second one is the motion should be in the direction of the applied force. And if I am pushing this board, I am applying a force, right? But here no movement takes place. Here what happens? No movement takes place. Even I am applying force. So here what happens? The work is not done. Only you can say the work is done when there is a movement and motion in the direction of the applied force. Here when I am applying force, but here what happens? The board is not moving. Yes? Here the work is not done. So work is equal to W is equal to F into D. F into D. So W is the work done in Joule. W means work done in Joule. And F is the force in Newton. F means force in Newton. It is measured in Newton. And D is the distance. D is the distance that is moved by a body in the direction of the applied force in meter. In meter. So this is the formula for work. Work is equal to F into D. W is the work done in Joule. F is the force in Newton. And D is the distance in meter. Yes? Now let us see the work done by symbol machine. Now let us see the work done by symbol machine. Work done by symbol machine. Yes? Work done by symbol machine. See, symbol machine helps us to use less force to do the same amount of work. Yes? So, symbol machines help us to use less force to do the same amount of work. And machines, they cannot do their work by themselves. Yes? They cannot work on their own. They cannot create energy. So it makes us the work easier. It helps us in changing the direction of the force. It helps us changing the amount of applied force, and it also helps in increasing the distance over the applied force. So these are the different things that the machines help us to do. It helps us to make our work easier by changing the direction of the force, by changing the amount of applied force, and by increasing the distance over the applied force. Work, the SI unit of work is joule. SI unit of work is joule. Now, let us see the types of symbol. There are 6 types of symbol. There are 6 types of symbol. Types of symbol. Now we are going to see the types of symbol. Yes, types of symbol. There are 6 main types of symbol. First one is the lever. First one is the lever. Second one is the inclined plane. Inclined plane. Third one is the screw. Fourth one is the wedge. Fifth one is the wheel and axle. And sixth one is the pulley. So, there are 6 types of symbol making, children. First one is the lever, second one is the inclined plane, third one is the screw, fourth one is the wedge, fifth one is the wheel and axle, and sixth one is the pulley. So, today I am going to discuss lever. And next class I will be discussing the remaining types of symbol. So lever. Now let us see what is a lever. So lever. First one is the lever. So lever is a rigid rod. What is a lever? Lever is a rigid rod, yes, that can turn freely. Lever is a rigid rod that can turn freely around a fixed point of circle. So lever is this is a lever. So lever is a rigid rod. Okay, this is a lever. It is a rigid rod that can freely turn around a fixed point. That is known as a lever. So this is the lever. So lever is a rigid rod that can turn freely around a fixed point. Yes. Now lever consists of following parts. Lever consists of following parts. That is, first one is the fulcrum. Lever consists of following parts. First one is the fulcrum. So this is the fulcrum. This is the fulcrum. Yes, fulcrum is the fixed point about which the rod turns freely. So fulcrum is this is the fulcrum. Fulcrum is a fixed point which the rod turns freely. That is known as fulcrum. Next part is the load. So load. Load means this is the load. So, load is the object that has to be lifted or moved from one place to another. Load is the object to be lifted or moved. That is load. Next comes the effort. Next comes the effort. Next comes the effort. So this is the effort. Yes. So the effort. Effort is the force that you apply. Effort is the force. Yes, effort is the force that you apply on a movement to perform task. If you want to lift anything, you need to apply your effort to lift the thing. So apply force to perform the task. So that is known as the effort. So effort is the force that you apply to perform a task. That is known as effort. Now, there are two more things, that is load arm and effort arm. Load arm and effort arm. Load arm is the point at which the fulcrum, that is of the fulcrum, is free at the point and also from the point at which the load acts. So here, from the fulcrum to the load, this distance, that is fulcrum to the load, is the load arm, and fulcrum to the effort, the point and also at which the fulcrum is on which the effort is applied, that is called the effort arm. So load arm and effort arm. So from the fulcrum to the load is known as the load arm, and from the fulcrum to the effort is known as the effort arm. So these are the different parts of a lever. Based on the position of the load, effort and fulcrum, they are being categorized into three classes: class 1 lever, class 2 lever and class 3 lever. So now let us see first the class 1 level. In class 1 level. Yes, class 1 level. So here, in class 1 level, you go into class 1 level. Okay? Or you can write like this, class 1 level. Class 1 level. In class 1 level, the fulcrum is located. The fulcrum is located in the middle. You can see the fulcrum is located in the middle. Yes. And effort is on one side and load is on another side. So this is the class 1 level. In class 1 level, the fulcrum is located between the effort and the load. Effort and the load. Yes, that is the class 1 level. So effort, so you can see the fulcrum is in the middle. It is located in between the effort and the load. Here, in class 1 level, the load and effort changes the direction of the force. Examples for class 1 level: scissors, claw hammer. All these are examples for class 1 level. Now let us see class 2 level. Class 2 level. So in class 2 level, so now let us see class 2 level. So in class 2 level, this is the level, and here in class 2 level, this is the load, In class 2 level, this is the load and this is the fulcrum. This is the fulcrum and this is the load. This is the fulcrum. Yes, the load, fulcrum and effort will be on the other side. Yes, so effort will be on the other side. So you can, this side will be the effort. This is the effort. This side will be the effort. Yes, so load will be, effort will be and fulcrum will be. So load is here, fulcrum is this side and effort will be on the other side. So in class 2 level, load is in between the fulcrum and the effort. And class 3 level, and here in class 2 level, examples for class 2 level, that is class 2 level, the example for class 2 level, nutcracker, bottle opener. So bottle opener, all of you know bottle opener. So that is a, so you take the bottle, that is the load, and you are placing the bottle in the middle and you are taking the bottle opener to open the bottle. So load will be in the middle, right? The load will be in the middle and the opener that you try to open, that is the fulcrum, and the force that you are applying to open, which you hold, that is the effort. So that is class 2 level. Class 2 level. Now let us see class 3 level. Now let us see class 3 level. Now class 3 level. Now class 1, class 2 and class 3 level. So here what happens in class 3 level, the effort is between the load and the fulcrum. Effort is between the load and fulcrum. So in class 3 level, so this is the class 3 level. So here what happens is the effort will be in the middle. Effort. And one side will be the load. This is the load. Yes, and another side, that is here, will be the fulcrum. Yes, so effort is between the load and the fulcrum. Understood? So here you can see the effort is in between the load and the fulcrum. And here examples, that is examples for class 3 level. Cricket bat, forearm, cricket bat, fishing rod. All these are examples for class 3 level. So class 1 level, based on the position of the load, effort and fulcrum, they are being categorized into 3. That is class 1 level, class 2 level and class 3 level. So class 1 level, you have seen that the fulcrum is in between the load and the effort. In class 2 level, load is in between the fulcrum and the effort. And class 3 level, effort is in between the load and fulcrum. So with this, students, let me wind up for today. Thank you.